Hello everyone, my name is Zhu Zhengxiang. I'm delighted to have the opportunity of making this presentation for the conference CCSC 2020. The subject of my presentation is revising the security protocols against network attacks based on the Event B. After a brief introduction of the background and content of my work, I will introduce the modeling of network attacks and the modeling of protocol improvement process respectively. Then demonstrate the usability of my method through a case study. Network everywhere. Internet, mobile payment, Internet of Things, 5G all use security protocol. However, these protocols are not always secure, and logical vulnerabilities often arise in complex operating environments. So various manufacturers issued patches to fix the vulnerabilities, but the practicability and availability of the patch was not guaranteed. For example, Microsoft patched the SMB Ghost vulnerability in March this year, but the patch was exposed in June with similar vulnerabilities. In this context, this paper proposes a generic framework based on the Event B method and Rodan platform to guide the revising of a security protocol so that the unknown successful attack can no longer take place upon the revised protocol. In this framework, we will model the protocol and attack behavior first, then the process of protocol improvement, namely patch, is successfully established in the model and the rationality of the improvement is verified. Before I introduce our work formally, I will give a brief introduction to the Event B method. The Event B is a modeling method proposed by Professor Abriel. You can look at it in detail in the book showed on the PowerPoint. The Event B model can generally be composed of machine and context components, which define the dynamic and static parts of the model respectively. Variable types, constants, axioms, and theorems are defined in context. Variables, invariants that represent the nature of the system, theorems, events, and so on are defined in machine. Events are the most important part of the Event B model that describes the behavior of the system. You can set local parameters, conditions for event execution, and actions to be performed after the event is triggered in EVNet. If modeling is correct, the proof obligation generated by invariants of abstract models should be proved to be in the current models and the concreter models. The Event B development approach is based on the refinement theory. There are three benefits to adopting the Event B approach. First, Event B method models from an abstract model, which is relatively easy to model. Second, each behavior of the protocol and attack is described by events in the model, which is modularized development. Third, refinement theory can ensure that the development results meet the agreed nature. Here's a formal introduction to our work, starting with some basic definitions. Because our work is to model the behavior of the protocol and the attack together, we need to define the agents in the model. Protocol agents that represent honest agents, and attackers that include renegade agents and the third attack party. We then classify the events in the model according to their handlers. Protocol event is the event performed by a protocol agent that describes the normal operations of a protocol. Attack event is the event performed by an attacker that describes the process in which the protocol was attacked. Public event is the event that has no explicit executor, or the event describes the changes in the state of the modeling. So how are these three types of events represented in the model? We added three access properties for variables in the machine part. As shown in the picture, we make the following rules. Protocol events can read and write protocol variables and public variables, without any access to attack variables. Attack events can read and write attack variables and public variables, without any access to protocol variables. Public events can only read and write public variables. By modeling according to this rule, we can clearly distinguish between the types of events. Based on the definitions and rules given above, we can build an Event B model. For example, Model 1 consists of 3 protocol events and 3 attack events, where event S represents the successful attack. There are at least 2 event execution paths in the Model 1. Normal protocol running path P1, P2, P3, and successful attack path, P1, A1, P2, P3, A2, and AS. The event AS that indicates successful attack in the successful attack path is finally triggered. A model like this, in which there is at least one successful attack path, is called the successful attack model.